Hello students, in my previous video I will describe about atomic mass, relative atomic mass and molecular mass, and we discussed that mass of atom is too small that can't be described in kilogram and other units, and therefore a standard unit is derived which is known as atomic mass unit, and that atomic mass unit is equivalent to the 1 by 12th part mass of carbon atoms, and mass of carbon atoms is 12, or C12 carbon atom is 12 AMU, and its 12 part becomes 1 AMU. And today in this video we discuss about what is exact value of 1 AMU, which is known as, at first we define 1 AMU or AMU, atomic mass unit, and here we write 12th part of mass of carbon 12 is called 1 AMU, or simply 1 unit mass. And what is its exact value, which is known as absolute value of AMU, atomic mass unit. And here we know that one mole of C12 atom or carbon atom having mass equal to 12 gram, and 1 mole of carbon atom having such mass, it means what? Or 6.023 into 10 to the power 23 atoms of carbon, because 1 mole carbon contains that much carbon atom, that is equal to 12 gram. That much atoms equal to 12 gram, and 1 atom of carbon having mass which is equal to 12 divided 6.023 into 10 to the power 23 gram. And what we know that 1 by 12th part of C atom or carbon atom equal to 12 divided 6.023 into 10 to the power 23 into 1 by 12. That 12 get cancelled, and remaining is here 1 by 6.023 into 10 to the power 23, that much gram. And when we solve this, divide this, we got 1.66 into 10 to the power minus 24 gram mass is equal to 1 AMU. And we can write 1 AMU is equal to exact value 1.66 into 10 to the power minus 24, which is called absolute value of 1 AMU in gram. And in this way we can calculate mass of proton, mass of atom in gram also. After that, Compounds are formed by combination of various elements in a definite ratio. And how much percentage found in a percentage of different elements found in that compound is called percentage composition of molecules of the compound, or simply percentage composition. And here we write percentage of various elements present in one molecule of the compound is called percentage composition. And how we calculate how much part of that element present in 100 part of a mass of that atom, that compound or a molecule is called percentage. As for example, what is the percentage of sodium, sulfur and oxygen atoms in sodium thiosulfate Na2S2. Get it? Here. The molecular mass of Na2S2, 2 into Na plus 2 into sulfur plus 3 into oxygen. And here 2 into 23 plus 2 into 32 plus 3 into 6. And here we can write 46 plus 64 plus 48, which is equal to 158. And once more here, and what we know that 1 mole of here, from that 1 mole of sodium thiosulfate contains 1 mole of Na2S2O3 having mass 158. And here 1 mole of Na2S2O3 contains that much grams of contains 2 into Na equal to 2 into 23 equal to 46 grams of sodium. 2 into S equal to 2 into 32 equal to 64 gram of sulfur. We found that here different mass of element present in that. 2 into 3 oxygen are there, 3 into S equal to 3 into 16 equal to 48 gram of oxygen. And now we found calculate percentage of different elements. Total mass is here given 158 and therefore at first percentage of sodium, that is equal to mass of sodium is 46. So 46 divided by 158 into 100%, found that 29.1% of sodium is contained. Similarly, percentage of next is here sulfur. And mass of sulfur present there 64, which is equal to 64 divided by 158 into 100%. And when we solve it, then we got 40.5%. Next here, percentage of next is oxygen. Oxygen mass is here 48 gram given. 48 divided by 158 into 100%. And when we solve, then we got 30.4%, not oxygen. And in this way we can calculate percentage of sodium, sulfur and oxygen. In any compound, when we try to find out percentage composition, first we calculate molecular weight. Then about that here in one molecule which elements are present in which mass, and then its percentage. As for example, again we calculate percentage composition of element in next compound. Suppose we take simple element, simple compound here. Question here, calculate percentage composition of aluminum and oxygen in the O atom in aluminum oxide. And here the given compound is aluminum oxide. And first we calculate its mass. 2 into aluminum plus 3 into oxygen. 2 into aluminum is here 27 plus 3 into 60. And when we solve 54 plus 48, which is equal to 84, here 102 gram. 102 gram is the molecular mass of aluminum oxide. Now 1 mole aluminum oxide equal to 102 gram. 1 mole or aluminum oxide contains how many of aluminum? So 2 into air equal to 54 gram aluminum. 3 into O, that is 48 gram aluminum, that is oxygen. Now percentage of aluminum equal to aluminum mass is given 54 divided by total mass. Here we find out 102 into 100%. And when we divide that, then we got nearly about 52.3% of. Again, percentage composition of oxygen equal to, here in mass we found 48 divided by 102 into 100%. And when we divide that, then we got nearly about 47.1%, 42.1%, 9%. Why? Because by adding these two, we should find out total mass is 100%. Total mass 100%, and due to that reason, percentage of aluminum is 52.9, oxygen is 47.1%. And in this way, we can calculate percentage composition of any element in given molecule of the compound. At first, we calculate molecular mass, then we find out the ratio of different elements with its mass, and then we change into percentage. And in next video we discuss about what is empirical formula, molecular formula, relationship between empirical and molecular formula, or simply formula weight, empirical formula weight, and then how to balance chemical equation, what are the different types of chemical reactions. Thank you.